Hi, I want to go back and review what we've been discussing in class and then push ahead and look at how we can create tables and relationships in Microsoft Access. So if you will recall, I presented a problem where I showed a flat file data set, and as we analyzed the data that was stored away, we saw that we were storing the data redundantly, and that in doing so we made it so that there were lots of errors, or at least there was the potential to introduce a lot of errors. So in describing how this could be remedied, I suggested in class that there are three themes that are embedded in this entire data set. One theme being employee data, a second theme insurance data, and a third theme being audit data. Okay, so we examine periodically the insurance policies and check for errors, whatever that may be. And so we discover, just in kind of an intuitive way, that there are three very distinctly different themes embedded in this data. And when that kind of thing occurs, it is more or less a guarantee that there's going to be problems storing it all in one big collection. So what I suggested was that we create three storage structures, one for each of these themes, and then store away the essential data related to each theme in its own separate but related storage structure. And so in doing this in class, I described the data that would need to be stored in the employee table, and you can see it down here. This should be exactly what I put on the board. So I don't need to repeat Kuntz 4 times the way I have in the original data set. I need to store one record with the essential data concerning Charles Kuntz, store it one time and one time only in its own separate storage structure. And I would do something similar for insurance, and in fact I'll show that here in a moment. And then in class I had you determine what should be stored in a third storage structure that stores audit data, and I will go back and show that again in my example as I go along here. All right, so let's take a look at how we would actually create these storage structures now. So I'm going to be using Office 2013, and one of the programs in that software suite is Microsoft Access. So I have Access set up on this computer so that it appears in the taskbar as a tool down here, and if I click on this shortcut, it will allow me to access existing databases or create a new database. And what I'm going to do is demonstrate how to create a new database. So I want to choose from among these templates blank desktop database, and when I do, it attempts to create a database by the name of Database1, and I'm going to change that name to DB1, and I will call this Fall 2015. Okay, so hopefully that's a unique name, because I've done this a time or two. And instead of storing it in documents, I'm going to browse the file system, and I'll just navigate to the desktop for the time being and save it on the desktop. Okay, so I've changed the file path to the desktop, and I'll execute a create command, at which point it being Microsoft Access, attempts to start me out by creating a new database table. Okay, so this is fine. as I mentioned in class, I wish it wouldn't do that, but the software is designed to do this automatically, and so you just live with it. It is showing me the database in datasheet view, which is not really what I want to see initially. So I'm going to switch over here with the current page being the file page. If I click over here and choose design view, then it's going to immediately ask me to give this table a name, and I'm going to store away the employee data, so I'll store it in a table called employee. And you'll see the view change. This is the view in which I create the storage structure itself. Okay, so I'm not populating the storage structure with data yet. I'm just building the table structure itself at this point. And this table structure needs to have several different columns, and I'm going to go with the column names that I have chosen here. So I'm going to have as a first column, instead of just ID, I'm going to have employee ID. So I like to name my columns so that they're preceded with the name of the table, and then an underscore, and then a descriptive name. So this will be the employee underscore ID column. And by default, the database management system wants to create this first column as an auto number column. Okay, so we've talked about this before, how database management systems give you the option to create a whole number or a integer value, and then rather than you're having to populate it with a unique number, the database management system will do that for you. So this is really a convenience, and it guarantees that every time you insert a row into a table, that field value receives a unique number. And although it's called auto number up here, it's actually, the underlying data type is long integer, with the emphasis being here on integer. Okay, so it's going to store whole numbers, and it's going to again create those numbers as you insert rows. So that one will be the primary key column, and you'll see that it's designated here with the primary key, so that happened automatically. And I'm going to highlight this much of it because I want all my tables to begin with employee underscore, and I'm going to do a Control C, copy that text, and then Control V to paste, and I'm going to name the next field LName. I'm going to make it type text, and I'm going to limit the number of characters to 25, not 255, which it's attempting to do. Okay, so I'll be able to type in characters with a maximum number of characters of 25, which should be sufficient for any name. And I'm going to also do the same thing to store first names. Same data type, short text, so store text, and I want it to store up to 25 characters. And then two more fields that I want are the date of birth field, and this one I want to change the data type to date time. I mentioned in class that calculating dates, if I want to do some date arithmetic, like subtract the employee's date of birth value from the current time on the system clock, that's a tricky operation if I don't use date time data type, because the number of days in the year vary, and because the number of days in each month varies, so it gets to be tricky arithmetic. Otherwise, if I make it a date time data type, then there's built-in functions that can perform date arithmetic. Another field that I want to put in here is the employee date of employment field. So what day did they start working for the company? And again, I'll make it date time data type. And if I go back and inspect the original data that we talked about, you'll see that I have 5 fields showing up in this example that looks like what I presented on the board. And if I come back here, I've got 5 fields that I've created for this table. Now, if I save and then switch back to the data sheet view, you'll notice that there's no data in here yet, but I have a number of new columns showing up. And I'm going to drag on these dividing lines and expand these columns a little bit so I can see the entire column heading, and then save, and then that'll be locked into place. Okay, so there we have it. We've just created our first table, and the next step in the process would be to do the same thing and create the insurance table, and then turn right around and do the same thing to create the audit table. Okay, now that we've seen how to create one table, let's just turn around and create the next one, which will be the insurance table. And this time I'm going to have to do this a little bit differently, because whereas before when I created the new database, it automatically set things up to create my first table, my employee table. Now that this database exists, if I want to create a second and all subsequent tables, I have to do it differently. I need to go to the Create page and choose Table. Okay, and I can choose a couple different options here, but let me choose Table Design. Okay, and I'm going to very quickly type in all the essential information here. Told you that'd be very quick. And I'm going to highlight this first field and apply a primary key. Okay, so I've now designated this as a primary key, and you'll notice that I have an employee ID field, which looks a little bit different than the way the other fields are named, and this will be used as a foreign key. Okay, so, oops, cap lock key was on. Take that, try that again. Okay, so I have a comment area over here, and if I want to type in comments, I can. So whatever I type in here is just for human consumption. Doesn't make any difference in terms of building the structure of the database table. But by naming this the same as the primary key field in the parent record, then it's going to be very easy to identify that field, which has a special purpose, as a foreign key. Okay, and I'll say more about foreign keys here momentarily. But I have now created my second table, and I'm going to click the Save button and name this Insurance. Tell it OK, and save one more time and exit out of here. And now I've got an insurance table, and if I open it in Datasheet View, I'll expand these columns a little bit so I can read the column headings. You'll see that one more. Okay, you'll see here's my primary key, foreign key, and then these are just informational fields. I'm going to expand this just a little bit more. There. Okay, so I'll save, and now I'm at a point where I need to create the audit table, but I'll leave that for you to do. And now that I have two tables, then I'll go ahead and show how relationships are formed. So in order to do that, I need to go to the Database Tools page and select Relationships. And I should get a dialog box that shows all the tables that the database management system knows about. And I will just shift click on this and say Add, and then close, and it will add the two tables that I have. So I'm going to see it in a view that looks like this. This is known as a database diagram or a relationship diagram. And now I want to create the relationships. Okay, so we had looked at this previously in class and determined that there needs to be a one-to-many relationship, and the logic of it would be if I pull out a row of data from this table, let's say for instance the row of data that relates to, I've lost my picture. Let's see, where is that? Oh, I haven't closed that up. Okay, well, we'll just fake it. If I pull out a row of data here in this actual employee table, maybe the row that relates to Charles Kuntz, which would be the first of 4 rows, then ask myself, all right, Charles Kuntz, the employee record for Charles Kuntz, how many insurance policies could it relate to? Well, it could relate to a dental policy. It could also relate to a medical policy. It could also relate to a vision policy. In general, we would say that one record from the employee table could relate to many records in the insurance table. And then what I suggested is that you look at the reciprocal. So if you put the employee record away, come over and pull out a record, any record from the insurance table, and then ask yourself how many employees does that relate to? The answer would be 1. So a policy will relate back to one and only one employee. All right, so we have a one-to-many relationship, a need to create a one-to-many relationship. So how do we do it? In the relationship diagram, if you go to the parent table, so you have to determine which one's the parent table, go to the parent table and drag and drop the parent table's primary key field onto the child table's foreign key field, then the database management system should generate a dialog box, and this is the process of how we would create the relationship. So it's suggesting that a one-to-many relationship be created from the employee table on the one side and the insurance table on the many side. So a one-to-many relationship, and it's suggesting that that relationship be based upon the values that are in the employee's primary key field, employee ID, and the insurance table's foreign key field, employee ID. And that's exactly what I want, is for the insurance table's foreign key value to store a value that corresponds with the employee's employee ID field, and that then provides me the pointer system that I need. So everything is communicated correctly. If there should be a problem, you can click here and change the field. So if you misfire with the mouse or something, you can edit this and correct it, but if you're careful, you shouldn't need to. The second part of this has to do with enforcing referential integrity, and so this is something I have not discussed yet, but let me go down this path now. I have the option to enforce referential integrity, and unless there's a reason to, a compelling reason not to do this, you should always enforce referential integrity. So the only disadvantage in applying this rule is that it's going to burn more CPU cycles, so it has the effect of slowing the computer system down a little bit. But the benefit is that if referential integrity is applied, then the foreign key field of the child record will be forced to store a value that occurs in the primary key field of the parent table. So if I have 4 records in here, record 1, Charles Kuntz, record 2, Mo Blanco, record 3, I don't know, record 4, I don't know. You know, if I have 4 records in there, then the first record has, let's say, an ID field value of 1, second record 2, third record 3, fourth record 4. Values 1, 2, 3, and 4 are legitimate primary key values for records in the employee table. A value like 27 is not a legitimate primary key value. There is no row in the table that has a primary key value of 27. So if I enforce referential integrity, the database management system will only allow child records to be inserted if the child record stores a legitimate value, that is to say, in this instance, stores 1, 2, 3, or 4. So if the child record stores a value in its foreign key field that maps back to some record in the employee table, some primary key value, some legitimate primary key value in the employee table, then everything's fine, and the database management system will allow that child record to be inserted. But if the child, if there's an attempt to populate the foreign key field of a child record with a bogus value, like 27 or 28 in this instance, then the database management system will stop and say there is no corresponding parent record with that foreign key value. So this is really a nice safeguard to make sure that we aren't pointing to something that doesn't exist. Now, there is one more thing I'm going to say here, just for the record. In most cases, that's what we want. We want the foreign key field to store a value that matches some primary key value in the parent table. There are instances, however, where we might choose to allow a child record to exist without there being a parent record. So if some benefit, for instance, is grandfathered in, and if an employee maybe dies or something, and benefits are continued for the dependents, as insurance might be provided for dependents in the event of the employee death, then we might want to let the insurance policy exist without it pointing back to an employee, because we might want to purge the dead employee from the employee table. Under those circumstances, which are unusual but not unheard of, then there's one more value that can be inserted into the foreign key field, and that's a special nothing value called null, N-U-L-L. So we can store null, and if null is assigned to a foreign key field of a child record, that is considered a legitimate value. It's not a violation of referential integrity, and that just tells the database management system that we're letting that child record exist without a parent record. So those are extreme cases, and we probably won't encounter them, but I go ahead and tell you that just so you know that it is possible for a child record in some circumstances to exist without a parent record. The other thing that becomes possible here when we choose to enforce referential integrity is we can apply 2 different cascade rules, and let me explain how these work. Cascade delete, I'll describe it first. Cascade delete works like this. If we're enforcing referential integrity, and if I apply cascade delete, then should I ever delete a parent record, the database management system will just automatically go out and delete any and all child records. Okay, so that's a rule that's applied to the relationship, and again, if the parent record is deleted, the child records will automatically be deleted. So you can't have a violation of referential integrity if you get rid of the child records. So you need to be careful of that. It's pretty powerful, you know, and if there's a reason to let a child record exist without a parent, you know, otherwise storing a null value in a foreign key field, you definitely do not want to turn that on. So you have to use some, you know, some good judgment in applying these rules. The other possibility is that we could apply cascade update, and the way this works is if the parent record's primary key does not use an auto number field, then this is probably useful, probably should be applied. So if the parent record or the parent table does not use a auto number primary key, if the table has been set up so that the primary key value has to be inserted every time a new record is inserted into the table, if the human being is responsible for providing that value, then there's the potential that later on that primary key value could be changed. And if the primary key value is ever changed in the parent record, then if cascade update is applied, that change will automatically cascade down to foreign key fields of all the child records. In other words, the child record's foreign key values will be updated with the new parent record's primary key value just automatically. And again, that only works, and the only reason you would want to do that, the only time when you would ever want to do that is when the parent record, when the parent table has been set up so that the primary key is not auto number. Okay, so you have to make some kind of determination here as to whether cascade update and cascade delete are appropriate. But again, unless you are experiencing degraded system performance because there's, you know, so much data stored in the tables and you are accessing it so frequently that it's causing the computer to slow down, then unless that's the circumstances, you'll want to make sure that enforced referential integrity is applied. So once all that's been set up in the dialog box, click the Create button. The dialog box will disappear and you now have a relationship, and again the notation here will describe the nature of that relationship, where one record from this table can map to many records in the insurance table, but one record from the insurance table maps back to but only one record in the parent table. So I'll let you rewind that and think about it for a while until you get it straight in your head. Okay, so that's how we create relationships. So what have we done so far? We have created two tables. You see how tables are created, and you've seen how relationships are created. Now, if you were doing this, given the nature of our problem, you would still want to create that audit table, and you would want to create the relationship and do all that before we move into the next phase, which is actually to populate the tables. And that's where I'll pick up in a moment. We're now ready to take a look at how to populate the tables, and I'm going to switch over here real quickly to the relationship diagram. So I go to Database Tools, Relationships, and you'll notice that the two table structures exist. The relationship has been created between the two tables. All this needs to be done before we begin the process of storing the data in the tables or otherwise populating the tables. So the first table I want to populate is the employee table, and if you think about it, this makes sense. If I put a record in the insurance table, one of the fields that I need to populate for each record is the foreign key field, and the parent records have to exist before a child record can exist. So if I need to populate the insurance table with a child record that relates back to an existing record in the employee table, that's all right. But if I have to relate it back to a record that doesn't exist, then I'm going to have to populate the employee table first. Hopefully that makes sense. So in our case, I've already added some data to both of these tables, and I'm now going to go back and add just another employee record, and let's say 2 insurance records, 2 child records. So to populate the employee table, I'm going to hit the tab key. So I'm going to place the cursor down here where it says click to add, hit the tab key. That'll advance me to the next row, and the employee ID column is set up as an auto number field. So if I attempt to type anything in here, the database management system won't let me. I'm going to hit the tab key, and now I'll add a new record. Okay, so let me add, let's say, how about Sam Blanchard. All right, so the employee's last name will be Blanchard. Hit the tab key to advance to the next field. First name will be Sam. Let's pretend his date of birth is 12/5/1965, and that his date of employment is 8/31/2001. Okay, so I've now inserted a record, and when I insert a record into a table, as soon as I put in that last field and hit the tab key, the database management system will automatically save that data, so I don't have to go up and click the save button up here. It's going to save every time I insert a row. So the parent record exists. This is record number 5. And now what we're going to do is pretend that we want to insert an insurance record. So I'm going to close up this table, go to the insurance table, and again tab and tab again, and we're going to relate this to employee 5, which will be Sam Blanchard. We're going to pretend that the policy number is 777, and we're going to pretend this is dental insurance. And we're going to pretend that this dental insurance was taken out on 8/31/2002, and hit the tab key and hit it again, and this time we'll add some medical insurance for the same employee. And so we'll pretend the medical insurance policy is policy 77. It's medical, and it was also the policy was taken out on 8/31/2002, and hit the tab key, and that record's written. And so I've just added 2 records into the child table. Now let me attempt to violate referential integrity just so you can see how that works. We know that there are 5 rows in the employee table. Let me try to put in a employee ID of 6, hit the tab key, say 555, I'll say medical, and put in a date, which will be 12/12/2012. As soon as I hit the tab key, it's going to tell me there's a violation of referential integrity, and there it is. You cannot add or change a record because a related record is required in the employee table. So this is where the database management system is going to block me, and I'm going to change this to let's see, I'll just change this to a 1 and give Charles Kuntz medical insurance now. hit the tab key, and everything's good. All right, so these are the fundamental things that you need to be able to do. You need to be able to recognize the themes that exist in a large data set and parse them out into individual tables. You need to identify just the essential data to put into the tables, and you need to be able to go into Microsoft Access and create the table structures, then create the relationships, and then populate the tables with data. Now, there's a lot of other things that we're going to learn along the way, but these are really, core critical things that you need to know how to do immediately. And so your assignment is going to be to watch this video and enter in all this data that I have shown in the insurance table and in the employee table. And then you're also going to have to create an audit table. Okay, so again, I'm not really saying that real clearly, so I want to make sure that this is understood. You do have an assignment. That assignment will be to create the audit table. You'll want to create the audit table immediately. You'll want to create the relationship between the audit table and the insurance table. You'll want to apply referential integrity to the relationship. And then once the three tables exist, you're going to need to populate them, and you have to populate them in some kind of logical order. So for instance, you can't put a record in the audit table as the very first record, because the audit table is going to then be on the child side of a relationship with insurance, and it's going to require that there be an insurance record first. You won't be able to populate the insurance table first because it's going to require that there be a record in its parent table, the employee table. So take the data that I show and put it into the proper tables, and you figure out what data then needs to be inserted into the audit table. And that's going to be your assignment, and bring any questions you have to class.